All right, so today we're going to talk about programming paradigms. There are a couple major ones, which is object-oriented programming and functional programming. And other people can correct me if I'm wrong, but I think by far the dominant paradigm is object orientation. So if you go out and get a job, you can be pretty sure that you're going to need to understand how object orientation works. So this question, obviously, as we kind of mentioned briefly before, is there like, which one is better, right? Is object orientation better or is functional programming better? And anytime anyone asks you a question like this in a coding context, the answer is always going to be, it depends, right? So it depends on what you're doing, depends on all kinds of things. So it depends on, strictly, code-based efficiency, engineering questions. It depends on human questions like who's on your team and stuff like that. All right, so there are some differences between object orientation and functional programming, but there are also a lot of basic similarities. So the reason to use any kind of paradigm at all, I guess the no paradigm would be procedural programming, where you're just writing instructions and everything executes from the top down to the file, basically like a script. So you could write code like that, but it's when it's small, it's fine, but the bigger it gets, the harder it is to maintain. So talk about modularity. So code that's modular, units of code should perform specific functions and be independent. So if you write code and you write a, think about Python module. So you have the Python built-in library and you have the regular expressions module in Python, right? So that makes sense. We were using that yesterday. Whole bunch of stuff has to do with regular expressions. Now, if Python included, HTTP server stuff in the regular expressions module, that might be a bit strange. So, it just makes sense to have things that do the same thing in the same package. And then as you go down in scope, to have things that only do one job and do that particular job well. That's kind of the ideal. So it should be modular, should be insofar as possible, a self-contained logical unit, and maintainable. So this one is more subjective, but other people need to be able to understand your code and work with it. So there's kind of a rule, or a rule of thumb, that you'll read code 10 times more than you'll write code. So reading other people's code, even reading your old code, other people coming after you and reading your code and trying to figure out what's going on and either debug it or add some feature or whatever. But you're going to be spending a lot of time reading other people's code, and you want other people to be able to read your code. So what counts as readable is obviously a little bit subjective, but so one issue might be like, don't use functional programming because it makes it less readable. Fewer people are familiar with functional programming, so use object orientation because there's already a built-in kind of audience for that. So you might count that as being part of maintainability, even using certain more advanced features. So when I was working at Motorola, we used Python fairly frequently, but it was used for scripts, not really for applications. So people knew how to use Python, but it wasn't like people weren't Python experts. And so I remember I was doing something and I used list comprehension to make an array. And the more senior coder who was checking my work basically said, just make that a for loop, because he wasn't familiar with list comprehension. So it's not like the most advanced counterintuitive feature of Python, but you have to know a little bit of Python and it's just easier. Everyone knows what a for loop is. So you just make it a for loop. It works, it's basically the same thing, but everyone knows it. So that's part of maintainability. So a lot of it depends on your local circumstances. Testable. So code needs to be decoupled, kind of has to do with modularity, and fully testable. We haven't talked about code coverage explicitly, but we'll probably do that soon at some point. But making sure that your code is in testable chunks so that you don't have a whole bunch of hidden logic somewhere in a large function that can't really be explicitly tested. And then lastly, so there are a whole bunch of other things we can talk about. These are just some basic ones. But lastly is dry, so don't repeat yourself. So you want to minimize redundant code. And an object-oriented paradigm has particular ways of reducing redundancy, and a functional paradigm has other ways of reducing redundancy. So the major one with object orientation is inheritance. So if I can kind of make my classes increasingly abstract to encompass different levels of functionality. So if I know that a whole bunch of components need to share certain functionality, I can pull all of that out. So instead of being in 20 places, I can put it in one place, right? So that's a way of reducing redundancy. All right. Okay, so let's talk about some features of some language features that are necessary for functional programming to work. So one of them is that functions need to be objects. So you'll see in functional programming that it's just functions everywhere. Functions being passed in as parameters, functions returning functions, functions returning functions that return functions. So it's just all just this mess of functions everywhere. So if functions weren't objects, if you couldn't pass them around like that, you wouldn't be able to do functional programming. So we'll just look at a simple example. I think we all kind of understand this idea in JavaScript, but so we'll just write up our own example real quick. I'm going to share my screen. All right. Is this big enough for everyone? Can you see it?
Yep.
Okay. All right. So I'm sure everyone is sick of typing console.log, right? I am sick of typing it. It's too long. Python's print is much nicer. It'd be even nicer if it was even shorter. So we can actually do that with JavaScript. So we can go at the beginning of our file and we can do log equals and I can come down here and I could do and that works, right? So I've taken this function, which is, ultimately an object, or at least JavaScript treats it like an object. So if I can do something like I can do log that's going to tell me function, but type of log. So if I look up logs prototype chain, it's ultimately going to tell me that it's an object. It's got object capabilities that it can use. So not only can we do this, we can also do conditional logic, right? So let's imagine we have an application and we have a development environment and we have a production environment. So in our development environment, we want to be printing out log statements all the time. So we're printing out all these log statements, but in production, we don't want that. So one thing we could do is maybe just get rid of all of our log statements or something like that. And then anytime we're developing, we just kind of have to rewrite the log statements. But that could be kind of a pain. So one thing you can do is just set an environment variable. So you can do something like So we'll do I'll call it something else. Call it envy, even though it doesn't make any sense. So this is our environment variable. We're actually going to use a node, some built-in node functionality to grab the environment variable. We'll pass it. And we want to deactivate basically log. So we have our function. Actually, I'm just going to paste from that. Where is that? All right. So I've got this production code right here. So my production code is right here. It's a function, and there's a log here. So I've left this in here right here. So when I'm running in production, I don't want this to do anything. But when I'm running in development, I want it to print out so I can see what I'm getting. So what we can do here is make this conditional. So console.log equals, let's see, equals actually I need to test here. So we'll do, put that. So we'll do so if our environment is dev, we'll set that in a second. Then we want normal console log, right? And if it's not, if it's production or anything else, then we'll just do nothing. So now we have we can add some logic. So we've assigned this to a name, but we're making it now dependent on the environment that we're running in. So we can do something like, what is it? envi, so environment equals dev node functions are objects. And we can see that this prints out. So I ran my production code and this log ran, right? But what if I run with a different environment variable? Then it doesn't print out. So I've taken, I've made a function that works conditionally dependent on my environment, and I've assigned it to a variable, and then I can use it in my code. I can leave it here in the code, and this can be in production code, potentially, but it's not going to be wasting resources by printing stuff all the time. So just objects or functions are objects. You can do anything with them that you can do with any other value, basically, in JavaScript. All right. Okay, so I'd like to do a quick activity now. So, well, first let's talk about higher order functions. So higher order functions are functions that take other functions or return other functions. So have we used higher order functions yet? So what can you guys unmute yourselves, or I think you can.
We have in recursion, right?
Okay. Well, so recursion isn't exactly. I mean, you could have a recursive higher order function, but recursion is just calling itself with usually with new parameters.
It'd be more like a sort or map type of functions.
Yeah. So can you tell me about map?
So map takes in a array and will generate a new array, and you can do something to each element in that array when you create the new copy of it.
Yeah. So what do you give to map? JavaScript map.
You give it a what's called a callback function, which is essentially you're telling it to do a function on each element.
Right. So you start with an array, you run map, it will generate a new array. It returns a new array. That's important. We'll talk about that in a second. So it returns a new array, and it will execute the function that you pass to it once for every element in that array. What about for each? Is for each? What's the difference between map and for each?
For each, calls a provided callback function once for each element in an array in ascending order.
Okay, isn't that what map does though?
But it doesn't. I think for each doesn't make a copy. It's destructive. It changes the original versus making a copy.
Yeah. So for each will modify the original array, and map does not modify the original array. So map will create a new array, doesn't touch the original, whereas for each will modify the original array and doesn't return anything. Okay, so but both of them are higher order functions. They take functions and then execute those functions for every element. So what I'd like for you guys to do now, hopefully this will work. I'm gonna stop sharing. And I'm gonna pause the record. I'll leave the recording for a sec. So what we're gonna do is do something similar to what we did last time. I'm gonna break you guys off into pairs in the breakout rooms. Hopefully I have it to where the TAs, let me make Encore co-host. Hopefully this won't include the TAs, Daniel, okay. And then you guys will go in your pairs and you'll try to come up with a solution to this problem. So what we want to do is write our own map. So we want to write our own map function that does the same thing that JavaScript's map does. It takes an array, it will take a callback function, and it will execute a callback function on every element of the array, and it will return a new array. So that's what we want to do. So here's the link. So I'm gonna put this link in the chat here, in the Zoom chat. Can everyone see that? All right, so go there. Don't write on the page, just copy that, and you can edit in your own browser or whatever environment. You could use REPL if you want to do it real quick, or you can do it in VS Code. And then we'll take 5 or 7 minutes and we'll see what we can come up with. So I'm going to create breakout rooms. And assign automatically.
Sir, I just want to give you a heads up. I notified Tom, but I am on the road, so all I can do is communicate with somebody.
Okay, that's fine.